a couple of terms. Contradiction, conditional, and identity. Three terms that I want to become a little more familiar with here. Actually, this term is the one that we might want to talk about first. A conditional equation is an equation that has a fixed number of answers. There are some answers, but there's only a fixed number of them, like previously we just talked about. Conditional equation example would be 6x plus 2 equals 4. That's a conditional equation because there's only a fixed number of answers. There's only one answer to that particular equation. Subtract 2, 6x equals 2, divide by 6, x is, reduce those by 2, you get 1/3. Yeah, so that's an example here of a conditional. A conditional equation only has a fixed number of answers. It has one answer or two answers or just a fixed number. Okay, that's called a conditional equation. What we mean by contradiction, well, contradiction, let me just give you an example. Let's say we have 6x minus 3 equals 6x plus 5. We go about solving that one. Well, we get the constants on one side, the variables on the other. Well, let's subtract 6x. Move the 6x, this 6x to this side, so we subtract 6x. What happens? 6x minus 6x, that gives me negative 3. 6x minus 6x plus 5, that gives me 5, because in both cases, the 6x minus 6x is 0, 6x minus 6x, that's 0. Here's what we wind up with. The variables have gone away. We're just left with the equation negative 3 equals 5. Well, obviously, doesn't make much sense. 3 negative 3 cannot equal 5. This is a contradiction. This is an example, or the original equation there. This is an example of what happens when you get a contradiction. That equation there, that's called a contradiction. In other words, you can't have 6x minus 3 equals 6x plus 5. It just doesn't work. Okay, well, solution set wise, you know, solution set over here is 1/3. Well, what about the solution set over here? You just can't have a solution. It doesn't have a solution. There is no solution, so it's kind of a sort of a trick question there. Solution set is there is not one. There's no solution. Or sometimes you might see this little symbol here, 0 with a slash through it. It's the empty set symbol is called. That could be an alternative answer here for this particular problem. Okay? So a contradiction is one where you solve it and it winds up having an answer that just doesn't make sense. The identity, well, similar thing happens as on the contradiction, but a little slightly different. If we do 2x plus 4 equals x plus 1 plus x plus 3. If we think about that one here, solving that, a little something else happens. We'll go about solving this one. 6x plus 4 equals, got like terms on the right side. You got x plus x or 1x, coefficient 1, coefficient 1. So combine those, you got 2x. And then combine the constants there, the 1 and the 3, you got 4. So you got 2x plus 4 equals 2x plus 4. Well, you might see what's going to happen here if we subtract now to get the variables on one side, subtract the 2x. Yeah. What we wind up with is, again, something happening that the variable terms cancel out on both sides. But in this case, we don't wind up with a contradiction. In this case, we wind up with 4 equals 4. That is, unlike the other right over there, that's not a contradiction. That is a true statement. Matter of fact, that's always true. What we have here is an always true statement. Referring back to the original equation now, that equation leads us to 4 equals 4. It's always true. That is always true. That is an example of an identity. When you get an always true equation, the equation is referred to as an identity. All right? So if we get a statement such as 4 equals 4, that's an example of an identity there. Let's talk solution set. Well, like we said, solutions-wise, this is always true. This is always true. In other words, then, x can be any number whatsoever. So the solution set for an identity is all real numbers. Always what you will have for an identity solution set. All real numbers. Anything can replace the variable here. It can be 1, it can be 3, it can be negative 100, positive 2/3, square root of 55. Doesn't matter. X can be any number whatsoever. Okay, so we'll just say all real numbers will cover it. All right. So what they'll sometimes ask you then is take an equation here. 5, say, parentheses x plus 2 minus 2, parentheses x plus 1 equals 3x plus 1. You know, we do want to solve that, but they also will ask, is it contradiction, conditional, or an identity? Abbreviating there, okay? Which one is it? Well, the way you tell is you solve it out. If we get x equals a number, that's conditional. If it's a false statement, contradiction. If it's always true, it's an identity. Just have to work it out. All right, so that would be distributing the 5x there. 5 inside the parentheses, I should say, so it'll be 5x plus 10. 5 times x, 5 times 2. Minus 2, distributing it, so it'll be minus 2 times x is minus 2x, minus 2 times 1 is minus 2. And that equals 3x plus 1. Got some like terms, don't I? 5x minus 2x is 3x. Then I got 10 and minus 2, so that's positive 8. That's 3x plus 1. Moving the variables to one side, I'm going to move this 3x, move it over, so it'll be minus 3x. So that'll leave me 8. 3x minus 3x is 0, so 8. 3x minus 3x is 0. 8 equals 1. Variables are gone. That is not true. 8 does not equal 1. So we get a false statement there. The original statement then, remember that, that's going to be a contradiction. Solution set is no solution. Or the empty set, easiest way to write it. Okay? All right, one more of those. Let's see if we got it. 4 minus x equals negative, parentheses, x minus 4. Is that one a contradiction, a conditional, or identity? Just solve it out. All right, 4 minus x equals, distribute, so it'd be minus x. Minus times minus would be positive 4. Add x to both sides, right? Well, minus x plus x, that's 0. So you just wind up with 4 here. Minus x plus x, we just wind up with 4 here. Again, we got the 4 equals 4. That is always true statement. That's an identity. And the solution set for identities, it's always all real numbers. So that would be your answer here. All right. So that should help, hopefully, for section 2.1.